And we're going to bring up Denny Grossman, founder and CEO, NuClarity.
So it's co-founder. So at NuClarity, we're powering the future with scalable, low-cost nuclear energy. We all want more baseload capacity for data centers, for emerging economies. We all wish we could decarbonize yesterday. And the last few years have taught us about energy resilience. And nuclear energy checks all these boxes, and it seems like the nuclear renaissance is finally here. But actually, nuclear energy is about 60 years old. It's not new in any way. And it's not been terribly successful at the West. It's been a devastating failure, basically. And the question is, what is going to be different this time? So if you do the research, it turns out it's not about public opinion. It's not about safety. It's not about nuclear waste. It's, as usual, about the money. By 1975, nuclear industry was already dead. It just didn't know it because it became too expensive and uncompetitive in the energy market in the US, and it's been spiraling down ever since. And so if we don't solve that problem, we're stuck. If we look at recent results, recent published contracts, latest large reactors are very, very expensive. As expected, they always have been, at least recently. And then there's the SMRs. These were supposed to solve the big mega project problem facing big nuclear, but it seems that they're on a megawatt, on a kilowatt basis, they're actually more expensive. So we're not going to solve this problem. There's going to be no nuclear renaissance, and we're going to be stuck. So we set out a mission. Understanding these things, we need to solve this problem, which is economics of nuclear. We studied what makes nuclear expensive. We charted out all the cost structures of the SMRs we could find, and we did something different. We found the major cost drivers and we avoided them. We found the supply chain bottlenecks and we worked around them. And the results are the L200. So we combined 3 known reactor types into something which has not been previously known, into a first economically viable SMR. It's 200 megawatts of electricity. It has extremely competitive LCOE and CapEx, which is competitive in the average energy market. It is cooled by liquid metal. It is fueled by standard, low-cost, off-the-shelf nuclear industry fuel. It also uses an off-the-shelf turbine generator set. Its small size, only 6 meters in height, makes it very efficient in placing it underground and protecting it. In the founding team, we have Hanan Mor, a very established serial entrepreneur on the business side, Dr. Ami Nagler, with 40 years of hands-on experience in nuclear and advanced reactors, and myself, Danny, with 25 years in deep tech experience. We've bootstrapped so far $1 million in the development phases, and we are going to open our pre-seed round in a few months. NuClarity is a European technology provider. Unfortunately, I'm the US track, so maybe I should change that. And we're targeting Eastern Europe for first deployments by 2032. If you want to be part of the journey, please keep in touch.
Questions?
Thank you very much. Could you elaborate on your go-to-market strategy by 2032? That's quite a long way in terms of startups, on financing, and predominantly client go-to-market, etc.
So right now we see a very strong pull from Eastern Europe in terms of nuclear, whether it's Poland, Romania, Czech Republic. So we see a very strong pull there with public sentiment, with decisions, hard decisions by governments, and there's a lot of momentum there. And there's also a nuclear ecosystem there that seems to be the natural place for us to start our first project. and to partner up with strong local utilities and engineering companies in Eastern Europe. This is kind of the geography, and we're actually in the process these days, as some of you may know, of finding out where the best place for us to start in. With respect to financing, it's a very arduous road to get to where we need to be. And obviously, we're going to be starting small with a pre-seed round. And very quickly, we'll be scaling up investments with bigger and bigger players in the VCs and also strategic investors, which are EPCs or utilities, and also getting governmental support, which is also abundant in these geographies I discussed.
Can you talk a little bit about the technology that makes your competitive edge? So you talked about the cost going down, but how did you do it?
So in the very few seconds we have here, there are basically two types of technologies: the traditional water reactors and the Gen 4 reactors, which are basically non-water cooled. For the water reactors, they are large because they need convection cooling when there's you don't want another Fukushima, and that means they're very high, and that means the building around them is very large, and they're expensive in that way. But they do use very cost-effective fuel, which is the standard nuclear fuel. The Gen 4 reactors they're not always, sometimes they're large, but they can be very small, very dense, and the surrounding infrastructure scales with that, and that's very good. On the other hand, they're using very, very expensive fuel, and it's expensive in two major ways. One is higher enrichment, up to 20%, which is very expensive. It's not commercially available. It's a big, big problem, a very big bottleneck, basically. And the second thing, they're not using uranium oxide fuel. They're doing something different, which again, the factories and these do not exist yet on a commercial scale. And these two factors make their fuel very expensive and a huge bottleneck problem. We avoid these two expenses and we do something different. We kind of use, and this is the hybridization I discussed, we're liquid metal fueled, but we're using traditional fuel. This combination does not exist.
And what makes it so that the SMR next gen won't be using some of the same methodologies?
Well, hopefully we'll get our patent granted, so we kind of cornered this combination. And it's also a game of time to market, right? If you get there first with the cheapest solution in nuclear plant scale, it takes years and years to get to market. So if I started a year ago, I'm quite a bit ahead of somebody who's going to find out next year that it's expensive, and it will change the design.
Thank you, Danny.